Hey guys, this is Pi 314159. This is my CFD project. So I decided to model two different exhaust systems and do a comparison analysis between the two. The reason I did this is I recently bought a car, and within 20 miles of getting down the road, I actually had a few problems. I had a check engine light come on that indicated I had a lean fuel mixture. At the time, I didn't have a ton of time to deal with it, so I took it to a mechanic and asked the professionals to sort it out. What the guy at the shop came up with was that what I had was a single exhaust installed on a car that came from the factory with a dual exhaust. He suggested swapping that back out to original state to see if that would fix the problem. I wasn't really sure that that was going to fix the problem, but in the end it actually did. So I thought it would be a good idea to model the two different systems in Fluent and put them under identical conditions and see what kind of differences I could come up with. So what I did was I went online, found schematics for both the single and the dual exhaust system, and then modeled them up in SolidWorks to use within Fluent. Now the one difference that I found between the two systems was this Y back here. Other than that, from the catalytic converter forward, the systems are actually identical. So I ended up modeling the two systems from the cat back. To do this, I had to make a few assumptions. So I did some research online, and this is what I came up with. Using a 2-inch diameter exhaust and assuming that my problem occurred at about 4,000 RPMs, I came up with an exhaust velocity off of the cat to be about 125.4 meters per second. I assumed that directly off the cat, the temperature would be about 350 C, and from the exhaust port, about 65 C. I also assumed the fluid to be 100% air, which we know is not necessarily true, but it is a pretty good approximation. And most importantly, because I was just doing a comparison analysis between the two problems, it actually allowed for me to make some of these simplification assumptions, because I'm really just looking for the differences between the two systems. So for governing equations, obviously we use continuity, momentum. I enabled the energy equation within Fluent to allow for heat transfer, and I also selected to use the K-epsilon model. This is it here, and obviously it accounts for eddy viscosity and deformation, and is used to account for turbulence within the system. So on to the things that everyone cares about, pretty pictures. This is a look at, these values are all in pascals, by the way, but this is a look at the single exhaust pressure distribution, and you see a max here of 244 straight off the cat. And looking at the total distribution, you'll see that it is a lot higher. Well, not a lot higher, but it's higher than the dual exhaust. Also decided to model some velocity streamlines. We'll go through here and play this real quick. Won't do the whole thing. 5 minutes isn't a ton of time. But one thing I was able to learn from this was that if you look within the plenum here, the exhaust doesn't have a ton of time to slow down and also cool down. And in this one, you'll see the difference. So here we see that the max here is 122, which, as you can see below, is about twice the pressure from the single exhaust, which is going to result in higher temperatures and just a whole variety of different issues. Same thing, did the velocity streamlines on the dual exhaust, and as you'll notice here, while the velocity is the same coming off the cat as we would obviously expect, because you have two mufflers here, you actually have a lot more time for the fluid to cool down within these plenums, and that's going to result in a cooler exhaust. It's going to result in less shear along the walls, and ultimately less problems for me. So moving on, also taking a look at some of these numbers. So heat transfer rate between the two, it looks like the dual exhaust actually transfers heat about twice as well as the single. Surprise, surprise. And then for the mass flow rate, it's also considerably higher. And all these things are just going to compound into an overall system working correctly. So in conclusion, I found that the increased pressure and the decreased flow rate in the single exhaust contributed more air to the system. And with that more air, my O2 sensors were triggered. Because there was more air in the system, it did sense a lean condition, which was then obviously solved by putting on the dual exhaust. Also, I just obviously everyone knows this, but I was thinking, car manufacturers design a system for a reason. They know what they're doing. There's a lot of money that goes into the research. Deviating from this just on a whim because you think that putting a single exhaust on a car is a good idea is, obviously can cause some problems. And also learn my lesson that maybe in the future I will have the car inspected by a professional before I decide to buy, and I would caution you to do the same. Thanks for your time.